In the bird on a wire problem, I made a clear statement in class, and a few of you ignored it. You should listen more closely. I said treat the cable as a tension, not as a normal force. It was said out loud, very clearly. So when you're told something like that, obey, I guess is the best way to put it. I'd say it nicer than that, but I really don't have it in me right now. So let's start with, there's a conservative force on the bird, gravity, acting downwards. This is not an unknown force. It is 20 newtons. The bird is 2 kilograms. Weight is mg. That's going to be 2 kilograms times 10 meters per second squared. That's 20 kilograms meters per second squared. Get the units right. A bunch of you had wrong units. I'm not grading units today, but you know eventually that's going to have to come up, right? There are 2 other forces acting on the bird. There's a tension out in this direction and another tension out in this direction. And I said to treat them symmetrically and that they are the same. So this is T1 and this is T1. They are the same. I said this out loud in class, but I need to reiterate it because 3 people in this class who had this problem decided that this would be their coordinate system. I should give you negative points for your quiz, okay? So if you don't understand why, you should probably write on your quiz right now what you did wrong. That coordinates have to be at a right angle to each other. You can't just decide, I'm gonna make this one X and this one Y. That's not gonna work at all. So that's frustrating. None of these are gonna work out so you can get 2 of them on the line. You're gonna just pick one of them. I would pick the one that allows for the certain amount of symmetry. So I'd make this one of your axes. So I'm making that positive Y and this negative Y. That leaves me no choice but to make my x-axis horizontal. Now, for you guys who didn't get this quiz, I think that this was the harder of the 2 quizzes for many people. I would encourage you to take notes because you have 4 of these in your homework. You need to be working on them. You have to figure out where to place the angle, and you had little choice. The pole was here, and it was indicated that this was 85 degrees. So your choice is to do this one, 85 degrees, because that would be alternate interior angles, or this one as 5 degrees because it's a triangle. Doesn't make any difference, but pick one. You have to use geometry to figure out your angles from time to time, and this is no different. So probably use that 5 degrees, but that also means that this one is also 5 degrees. They're symmetrical, so I really only have to work on one side. So I'm gonna work on this side. I'm drawing a triangle that will help me take that force and break it up into its components. This one is gonna be T1 sine 5 degrees. This one's going to be T1 cosine 5 degrees. Any question about where those came from? Okay. They're the same on the other force. So I'm drawing them in there. It's redundant though. This next part was missing on a lot of quizzes. So I need to see this. So you need to make it pronounced. I need to see that you are thinking about the net force in the X direction and that you're thinking about the net force in the Y direction and that you are going to give me a list of forces in each direction. So if you look at your paper and you don't see that, something like this, and then below it, you listing out the forces, choosing direction, next time we do this, which is very likely tomorrow, you're not gonna be able to receive full credit. Apply Newton's laws. I wanna see this step. Does everybody understand? Are you sure? Because tomorrow when you don't do it and you say, why did I get points off? Even though my answer's right, I'm gonna say, because I didn't see this step, and I want to. In the Y direction, there are 3 forces. There's this one, and this one. So there should be a list of 3 things. So T1 sine 5 plus T1 sine 5. minus 20 equals 0. Now that's going to get me the answer, but you have to apply Newton's law. So I should also see T1 cosine 5 minus T1 cosine 5 equals 0. There are two forces that are in the x direction. One's to the left, one's to the right. So one's positive, one's negative. The answer can be produced here. So this is the only one I actually have to solve. This is 2 T1 sine 5 equals 20. You solve that for T1, and T1 ends up being like 114.7 newtons. Make sure your calculator's in degrees. Any question about this one? Let's see, I had a box on a ramp, and the ramp was inclined, was it 40 degrees? Pretty sure. So there's the ramp, here's the box, and there's a person pushing it. So take all of that, dip it 40 degrees, there we go. I would have more sympathy for people who had the angles in the wrong spot, except I made such a big deal about it yesterday in class. So I'm not sympathetic here. Get it right. And please, get it right the next time, every time. I said to you, there are some things you could just memorize about this, and gave you a day. Please, don't waste any more time. Get it memorized. This angle is 40 degrees. I'm going to go through how we know where the angle goes again. So make sure you have something that tells you this and study it, because you're not going to get your notes anyways, but you need to be practicing. The weight's downwards. There has to be and it's 50 newtons. 5 times 10, 50 newtons. There's a normal force that is perpendicular to the plane. And I said that the person is pushing. So a lot of people listed this as another normal force. Fine, I don't care. I don't care what you write here. I wrote F with an A next to it. So an applied force by the person. These are at a right angle to each other. You have to draw on a free body diagram. You want to get this right? Draw on the one aligned with the normal force first. As I said in class, the angle goes between the axis aligned with the normal force and the weight. So if you draw that one in first, you can't mistake where to put the 40 degrees. Otherwise, you're going to see an arrow like this and 2 points off. Well, you're in good company. But you won't be tomorrow. You're going to do it right. All right, both axes. I have to break up the one off-axis force into components. I still saw people taking it all the way down to here and then drawing this in. So I slapped it with red pen to remind you, no, don't do that. The right angle goes against the axis. Something like that. This is always going to be mg cosine theta, and this one's always going to be mg sine theta. Always. If you line everything up the way I'm teaching you, those will always be the components. I still want to see you complete the problem. So net force in the x direction equals 0. Net force in the y direction equals 0. So if I label this positive y and this positive x, in the x direction I had the applied force minus mg sine theta equals 0, or FA equals 50 sine 40. That's it. So FA, 32 newtons.
Attention teachers and students, in about 3 or 4 minutes when the bell rings, you will be reporting to your homeroom. Seniors, you will just be taking our panorama survey. Freshmen through juniors, that's 9th, 10th, and 11th grade, will be taking your PSAT digital readiness test.